Most of us are very familiar with our solar system. We can name all the planets and we don't really think much else of it. But to an inhabitant of a distant star system, gazing towards our star in their night sky, we might actually be considered to be odd. But one thing we can almost be certain of is that we aren't exactly unique. Our star and the planets that orbit it are quite a common arrangement for our galaxy, with the exception of Earth, of course, which contains intelligent life. So then, I'd like to give you a tour of some not so common star systems. Star systems which Earthlings and far-off aliens would both agree are rare and unique. The first oddity isn't necessarily the star system, but more so the star itself. This is the star known as Przybylski's star, or alternatively, if you're a bit dull, HD 101065. Flows off the tongue, this one, doesn't it? The uniqueness of this star is actually quite subtle, however, and wouldn't be noticed at first sight. But when you use a star's spectrum to try and find out what elements the star contains, something truly strange would be revealed. Unlike basically all other main sequence stars, this star contains almost no iron and nickel, but does contain very high amounts of elements like thorium, cesium, ytterbium, and uranium. This doesn't really fit into any other stellar spectral class. The star is also hypothesized to contain even rarer, more short-lived actinide elements, such as Einsteinium, which we've only so far managed to observe after the detonation of a nuclear bomb. So what exactly is going on here? One hypothesis involves something called the Island of Stability. These are essentially possible isotopes of super heavy elements that may have a much longer half-life than the known isotopes of these elements. This includes elements like flerovium or unbenillium. These elements could be responsible for creating the actinides visible in the spectral analysis, as they resupply these elements at a rate equal to their decay. There is an alternative explanation, however. Want to take a wild guess at what it might be? Yeah, it's aliens. Obviously. These aliens are either attempting to get our attention by creating these odd stars, or are just dumping all of their nuclear waste into their stars. Which does seem a little bit overkill, if you ask me, especially when an alien species of this caliber ought to have mastered fusion, but it's not impossible. PSR J17191438. Does that name ring a bell? Of course it does. It's just so catchy, man. But after I tell you about it, it might just stick around in your brain's random general knowledge section. This is a pulsar, and this pulsar has a planet orbiting it. This may seem like a relatively normal arrangement at first sight, but there is more than meets the eye to this planet. Because you see, PSR J17191443b, fuck it, let's just call it Planet B, isn't actually a planet. It's quite literally a giant gemstone. That's right. The planet orbiting this pulsar is a giant diamond. A diamond 40% the diameter of Jupiter, but just as massive. This, not a planet, has a very tragic backstory, as it wasn't always a giant, dense hunk of carbon. This was once a star, caught in a binary orbit with another, as many other stars are. But when its companion star died and went supernova, it was stripped of all of its layers, leaving behind a cold, dead, white dwarf core. Essentially a bunch of carbon and oxygen the size of a large planet. It now orbits the pulsar with a period of just 2 hours. But it gets even stranger, because it has been recently hypothesized that Planet B is not just a dead white dwarf star, but might in fact be a small, 1 kilometer wide chunk of quark matter. If you recall my video on strange stars, I go over and explain quark stars, which are basically a rare, hypothetical variant of neutron stars. If 2 of these quark stars collided, the system we see here may have been formed. Either way, it's truly unique and shows us just how intriguing certain things in our galaxy can be. The planet TOI 849b orbits a star almost identical to our own, a G-type white star. So far, nothing seems off, until you realize that a year on this planet is equivalent to 18 hours on Earth. We can calculate its orbital radius to be roughly 0.016 astronomical units, or 2.3 million kilometers from the surface of its star. For reference, Mercury is 51 million kilometers from our star. Sure, our solar system is a little odd in the fact that all the planets are so far away from the star, but this planet is also the most massive known rocky body out there. It's 40 times as massive as the Earth and around the size of Neptune. It may be a Chthonian planet, a gas giant which has had its atmosphere stripped away. It has a surface temperature of 1500 degrees Celsius, which is almost as hot as my bed in summer. This next one is a totally normal Earth-like world. It has plenty of water, and it's in the habitable zone of its star. It's called K2-18b, and it's actually a deadly hellscape. It's more like a gas giant than a rocky planet, covered in superheated and supercompressed seas, where water exists in a state between liquid and gas, with a hydrogen atmosphere. So we shouldn't really be in any rush to get there to go for a swim. Saturn has a stunning ring system, the thickest and brightest in our solar system in fact. They won't be here forever, but they certainly are special, aren't they? Well, planet J1407b seems to be the final boss of ringed planets. The planet itself is 20 times more massive than Saturn, and the rings span 180 million kilometers. For reference, the distance between the Earth and the Sun is 150 million kilometers. This planet was found by observing the light emitted by the host star and studying how it was blocked. These rings must be orbiting in a retrograde manner in order to survive the gravitational tidal forces from the host star. And for the final interesting or unique star system, it's Sol. When I said that we are a common arrangement, okay, we aren't that unique or strange at first sight, but there is one thing I omitted. As it turns out, it's actually a bit strange to be as far apart from our host star as we are. Most other star systems out there could literally fit in the gap between the Sun and Mercury's orbit. And after Mars's orbit, the distances become absolutely ridiculous, with light from the Sun taking 40 minutes to reach Jupiter. Why is this? Well, it's not that clear, but it certainly does mean that some alien life form out there could potentially mark a site as being very unique indeed. If you got to the end, then thanks for watching this video, and I'll definitely see you in the next video, which will be of a more special kind of nature. But anyways, thanks for watching.